Today we are going to discuss NQR, which is nuclear quadruple resonance. In this video, we are going to discuss what is the basis of the NQR, how the NQR actually happen, or the mechanism behind it, and I'm going to show you some example of it. So let's get started. NQR actually happen when I value is greater than half. Which is a magnetic quantum number, nuclear magnetic quantum number. For example, these three atom, in these three isotope, I value is greater than half. So when the I value is greater than half, quadruple is generated. There is a quadruple moment. Quadruple moment actually average of the nuclear charge which have maximum I value in the z direction. So I value is greater than half, and quadruple, there is a quadruple moment in these three isotope. So when the I value is greater than half, and suppose they are in the molecule where there is asymmetric charge distribution due to the variation of electronegativity of the atom in the molecule. So there is a new term which is called EFG, electric field gradient, which is generated, and there is an interaction occur between these two. So when there interaction occur between the EFG or electric field gradient and the quadrupole moment, then there is a degenerate quadrupole state is gonna create. That is the basis of the NQR. Now we are gonna show some example. Here's the two example. Those two are in trigonal bipyramid structure. So in first example, 3 chlorine are in the equatorial position. 1 fluorine is the axial and 1 chlorine is another chlorine is axial position. Remember, what is the NQR peak for these two example? Remember, only we are going to discuss only chlorine, because chlorine will show quadruple moment. So NQR peak only depend on chlorine, not fluorine, because their chlorine have I value which is greater than half. So we are only concerning about chlorine atom, not fluorine. So in first example, 3 chlorine atom are in equatorial position and 1 chlorine atom is axial position. So for these 3 chlorine atom, they are gonna show one peak because they are in same environment, which is in an equatorial position, and for this 1 chlorine atom, they are gonna show one peak, which is a 3:1 ratio. For this example, What will be the peak? Pause the video and try to solve this. For these two chlorine atoms are in the same environment, so they are gonna show one peak. But these two chlorine atoms are in the different environment, which is in axial position. So they also gonna show another peak, but they are in the same height because both have two chlorine atoms. So ratio will be 2:2. So that is the NQR peak of these two compounds. Now we are going to see another example. Here is another example where two chlorine atoms are in the same environment. Remember, we are only discuss about chlorine atom, or maybe it may be a bromine atom because they have the magnetic quantum number value is greater than half. So these two chlorine atoms in the same environment, but these two are not. So for these two chlorine atoms, you're gonna see only one peak because they are in the same environment. But for these two chlorine atoms are in the different environment, so what will be the peak? Pause the video and guess it. One peak for the one chlorine atom, another peak for the another chlorine atom. So there is a two peak for this compound, but for this only one peak.